there. So a couple of things that we have covered. We have covered multiple files in C language, or rather what I mean is working with multiple files in the C language. We have talked about pointers in good depth for people to understand. We have covered C structs also in good depth for people to understand. We have seen how we can do array of structures, or structure arrays rather, structure arrays. Okay, we have done all of that. Pointers to struct. So a pointer that basically keeps addresses of struct, pointers to struct, structures, all that kind of stuff, right? And in general, I think the overwhelming sort of message that we have been talking about here is really, how do we come up with dynamic arrays? I think that was dynamic arrays. How do we come up with dynamic arrays? And for this, we discussed matters related with dynamic memory allocation. Okay, and this dynamic memory allocation, we covered malloc, we covered calloc, okay, we covered realloc. Let me bring that up. Realloc, and lastly, we covered free, because once we assign memory using either of these three techniques, malloc, calloc, realloc, then we need to free that memory because that memory does not, the memory manager does not, there's no garbage collection in C. So we have to free that particular memory. So that's an important thing to think about. So today we are going forward with the same discussion, but most importantly, I am going to start now thinking more about vectors as seen in C, or rather, how would we implement, the overwhelming question is, how would we implement vectors in the C language? How would we implement vectors in the C language? Does it make sense? Okay. Is this all good? Are there any particular questions regarding any of these items that have sort of reference that we have already covered? Anybody? No. Okay, that's good. Okay, people are saying no. That's awesome. So let's do this. Let's go back and sort of revisit arrays in general. Okay, so we saw a couple of things. So the first thing I really do is ask you a question and say, if we are creating a dynamic array, what in terms of variables do we need? Okay, so this is a question. If we are creating a dynamic array, okay, then what in terms of variables do we need? Okay, what in terms of variables do we need if we are creating arrays, dynamic array? So I'm waiting for answers now. If we are creating a dynamic array, what in terms of variables do we need? I want to save this as a C file. Keep going. If we are creating a dynamic array, what in terms of variables do we need? What kind of variables do we need if we are creating a dynamic array? Well, Hitesh said we need a pointer, right? Okay, so pointer, which shall keep the address of the first element of the array. or the holder, really, the holder for the address. So we need a pointer, okay? We need a pointer, and this particular pointer, its data type, really, its data type for this pointer is going to be the kind of data, the kind of data that we want to keep, whether integers, floats, doubles, etc. Kevin says we need a variable to count how many items are stored. So variable to count how many items are stored. Now, can I ask you this, Kevin? When you say variable to count how many items are stored, do you mean a variable that tells us the actual capacity for the array, or do you mean a variable that tells us the main items, okay, the number of items inside the array at single point in time? What do we mean that? Variable to count how many items are stored. Do we mean items which are currently in the array at this time, and then we keep incrementing these variables as we add more items? Or do you mean a variable that tells us the actual size of the array? The total amount that can be put in array to count how many times are stored. Okay, variable, okay, to tell, to inform us the capacity of the array. Do we need one more thing? If you're working with a dynamic array, so variable to inform us the capacity of the array. So what we mean really is this: if we just think about this from an angle of a fixed array, let's imagine a fixed array of integers. I can say int names. So names is the name of the array. So we can say names is an array. So I see these brackets, I say it's an array. Names is an array of 10 integers. So I need names, and remember what we said. The name of an array is a pointer that holds the address of the first element. The name of the array is a pointer that holds the address of the first element. So I have the pointer here, names, and I have 10 here, which is the capacity of the array. Would I need something else in order to work with this array? Would I need something else? Would I need any other variable if I am working with an array? In the course of me working with an array, would I need any other variable? Let's take this as an example. If we had this array called nams, which is nams is an array that keeps 10 integers. If I wanted to populate this array or to work with this array in any single way, would I need another variable? No. Okay, Hilta says no. Someone else? Yeah, Ethan says like a variable to cycle through the elements. Yeah, we need an iterator. Oh yeah, thank you. We need an iterator variable, an iterator variable, an iterating. Yeah, so we need something like this. What do we mean? We need something like int I, and we can start with I being 0. So for example, we could say for I equals 0, okay, I less than maybe 10 in this case, I plus plus, and then we can do whatever we want with our array. Names at I is equals to, maybe we randomly allocate items like that. See that? So if you think deep about working with an array, a dynamic array, okay, or any other array for that matter, we sort of need 3 variables really. We need the array itself. In this case, when it's a fixed array, the name of the array is a pointer, which basically keeps the address of the first element. And then we need the capacity of the array, which is this guy here. And then we need an iterating variable that really, this variable is total items, really. If you think about it more, is total items at any single point, at any point, okay? Total items in the array at a certain point or time. Correct? So for example, if we start with I being 0, as these I loops, so once we put one item in, I will be updated to 1 to say that we have one item. And then I will become, if we put another item, we'll put it at the index where that item is. And then we increment I again, I becomes 2, and we can keep going back and forth, back and forth, back and forth. So if we were to see this as an example, I could just create main here, and then we see that's an example. Okay. All right. So if you look at this, what we are doing here with our array here, and we can count the number of items. I can say printf here, which is going to print for me integers one line by one line. And nums I here, I can put an item at a particular address, and then the items that we have. If I was 0, it means we have one item, and so on and so forth. Now, if I run this, which hopefully is not a big problem, let's clear this, and then we can go to, okay, I think the file is already there. GCC, we're just going to call the output file, and then we can call it main vector. We run this, I think we made some sort of mistake. We have not done the include, so we possibly need include stdio.h for now, just because we are going to be doing some printing. We are not doing some scanning yet, but we're doing some printing. All right, so we run this. Okay, I think we still have one more problem. I plus 1. What are all these problems? Rand. Okay, we need stdlib because we're using rand. I forgot to do that. stdlib.h. We can do that, and we can do that again. Okay, I forgot to put a semicolon somewhere here. All right, and then we can keep going. So we do that. I think there's some warning somewhere, not used by format string. So okay, we still have one more thing up here that we need to print out. Sorry about that. Someone should be telling me. Okay, so that's good. We run this file, and we can be able to do that. So when we so the items, remember we did a red max, a rand here. So we're getting some values between 0 and 44 or 45. And so we have 10 items. So every single point as we loop through the array, we know when we put 22 here, we have 1 item, 2 items, 3 items, 4 items, etc., etc. So essentially, we need 3 variables: a pointer, which basically is the array, or rather it keeps the address of the first element of the array, a variable to inform us the capacity of the array, and an iterating variable, which really also tells us the total items in the array at a certain point in time. Okay, so we need those 3 things. And turns out we possibly need to work with these things in tandem, so that when we reference the array and we start adding item to the array, then we sort of increment the total items in the array. And we need to increment these total items in the array by paying an important reference, and by paying an important reference to the capacity, so that we don't go above the number of items that are required in the array. Good. All right. So remember, we can put this, we can extend this to to a dynamic array. So this was a fixed array. If I wanted to make it a dynamic array, I make this a pointer like that. So nums now is a pointer to an integer. The memory has to be allocated dynamically. So I'll use malloc here, and I want to have size of integer, but I need to know the number of items I need. So maybe I can say int size here. And let's say we start up with the size being 7. I don't want to read in the screen. So if size is 7, I'll just come here and say size multiplied by size of integer. So I know I want memory manager to give me enough memory that can keep 7 integers. And malloc returns to us a void pointer. So I want to typecast this to an integer pointer, so that because our array is going to be array of integers. So we do that. So malloc, it mallocs up the size for me, and then gives me a void pointer, the start of the address, and I typecast that to an integer. Now I know that malloc can return null from last time. So we can say here, if names is null, then what? Then maybe we can printf out printf like this, and we say, well, there was no memory. We can say no memory up here, and we can sort of exit this code with code maybe 1 or other values that we might come about. So of course that would mean that after if there is memory, then this is not going to be used, and therefore we are going to come to this size, and then we can be able to go on with it. So this variable I, we can change it maybe to, we can call it total items or number of items, doesn't matter. So maybe I can say number of items, like that, number of items. So it's basically keeping the total number of items for me in the array, number of items. So now initially we have 0 items in the array. So 0 items in the array. Here we are checking whether number of items will stop putting items into the array when the number of items is the same as the capacity of the array. So the size here is the capacity. So I'll copy this and I will paste it here. And so I'll keep incrementing the number of items immediately I add things to the array. Okay, yeah, something like this. Or even better yet, we could have done maybe a while loop so that you can see it in a better depth. So we could say while number of items is less, where number of items is less than size. Okay, let me get this, maybe this might help you a lot. While number of items is less than size, then add something to the array. Okay, add something to the array, which is what we are doing, and then increment the number of items. So number of items plus. So this is to say, well, there's one more item in the array, and then we can print whatever items they are. So now instead of having I, we'll have number of items here. This will be number of items, but because we just increment it and we want the index, we'll always have to -1, and here will be the number of items. So far, so good? Okay, so I'm going to save this and I shall run it. No problem. I save file and still we get this. Our size is 7. So because our size is 7, then the values here are 7. Remember, we are not seeding our random generator, and because we are not seeding it, that's why we are getting the same values of here. Okay, so that's good. So far so good for everybody. Yep. Okay, so we haven't done anything much, really. What we have done is we have just decided we are going to have an array called nams here, the array is going to be as big as 7 items, and we create a variable called number of items that is tracking for us the items in the array at any single point in time. Now, what do you think would happen if I did this? Supposing I said number of items, I put it up here and I said number of items plus number of times plus is equals to 8. What would happen? Would this cause problems to my code?
I think it would.
What kind of problem would it cause?
It wouldn't it not do anything because it's not like before the while loop?
Mm-hmm. Well, yeah, I think that's a good point, right? So it will just increase the number of items and say number of items is whatever, it's 15, for example, right? Right? I think that's what you do. It's not going to cause any errors, whether logical or otherwise. We can do that. It's not going to cause any problem. It's just going to say 15 here, right? It's going to say the number of items is 15. But we know that if truly the number of items should mirror the work that the array is doing, or if we want the number of items to actually reflect what is going on with the array, then we should be doing something like this, correct? Right? We shouldn't be incrementing the number of items when we are actually not using the array. So in essence, what we might want to come up with a way that we can group all these things together. We can group all these 3 variables together, right? We might want to group them together so that when one moves, everything moves as well, correct? How would we do something like that? How would we go about doing something like that? How would we group these things together, the pointer or the array rather, and the capacity and the iterating variable? How would we group them together such that whenever we make a change, we are basically making a change? Well, we are basically moving, they are all related. And because they are all related, we want to ensure that any changes done are reflective of what we actually want to be done, or forces us in a way to sort of make changes to when it's required. Sometimes you can never. Someone? What do we need to do? Any suggestions?
Would we use a struct?
Ethan, yes, we could use a struct, right? Yeah, why not use a struct? So let's come up with a struct up here in main, sorry, up above main, because we want it to be seen everywhere. And we're going to say struct, let's just by maybe calling it my array, I don't know, just to make it easier, my array. And now what I'm going to do, all my 3 items, the one we said there to create a dynamic array is needed, we're going to put them together. Nums, which is basically pointer to the array, a pointer to the array, or let me call it the array itself. Okay, the array itself. Then size, which is capacity of the array, and int, maybe we call it number of items, right? So I'm just call it say number of items, or we can just call it items. Like, let me call it items just to make sure that everything is nice and simple. Int items in the array. So far, so good. So I'm just, these 3 things that we said we need, I'm just putting them together up here. Nums, which is the array itself, the size, which is the capacity of the array, items, which is the number of items in the array. All right. And then I'm going to typecast, to create type def for this so that we are able to work with it. And there we are. Okay, so how would it work? Again, nothing, no magic. We just need to create a variable of type array that then can help us access these things. Do you see that? So we could get a variable called array, maybe my array, I don't know. Let me just call this array like this. And then I can just say my array. So far, so good. So my array here is an instance of an array. And because my array is an instance of an array, how many, during runtime, how much memory will be allocated for my array? How many
12
variables?
bytes.
How many? Oh, 12 bytes. That's correct. So we need 12 bytes, right? 12 bytes, 4 bytes for the pointer nams, 4 bytes for the size, and 4 bytes for items, for the number of items, this variable, number of items. Okay, so we need 12 bytes that are given to us. And it's easy that we have that now to access every member, of this structure. It's as easy as saying my array, I'm just going to copy that. I'll just my array dot nams. So first of all, I'll say my array dot, I can start with the size and say size, maybe I give it a number like 7, like what we had before, right? So my array dot size is equal to 7. I was starting with the size of 7, which is the capacity of the array. What would be my array dot items? My array dot is equal to 1. How many items do we have in the array? At the beginning, how many items do we have in the array?
People are saying 0 in the chat.
Oh yeah, and that's correct answer. Okay, so let me put the chart down this side. Oh yeah, that's correct answer. We don't have anything in the array at this time, right? We don't have anything in the array at this time. So number of items is 0. Awesome. Number of items is 0. So, and we can keep it like that. The number of items in the array is 0. Then, well, we are creating the array now, which we have, but this now we no longer have something called size. We have something called my array dot size. So we have that. And so when we create the array, remember this can be returned as null. So we can as well have that, my array.num. So we check whether it's null, etc., etc. We no longer need this guy here because, well, we have this guy called my items, which is what we are going to use. So we're just going to check my array.items less than my array.size. Basically, that's checking for us whether the array is full or not, right? Correct? That's basically checking whether the array is full or not. If the array is not full, then add items to the array. So my array nums, which is the array, number of items is my array.items, like that. And that will add items to us. If we want to increment this, we can do increment it. This will increment the number of items in the array. This will print out the array. So I'll just put it here. And because this is for index, so I'll just do -1. And then this guy will be here. And that will print out for us there. And this was just extra info, so we're going to delete it out. Okay, and we can save this. We try running it now. Okay, no problem. We do file, we run it, and again, we get the same value as we got before. So nothing has changed, right? Nothing has changed. The only thing we did is we have created something which is a struct, which is keeping for us or helping us to mask the array and all the variables needed to work with the array. Correct? So we have created a structure that is masking the array and the variables needed to work with the array. So far, so good? That's what we have done. Now, well, actually, when we mask an array like that and the variables needed for that, we call that a vector. So we can change the name array and call it vector like that. Here we call it vector like that. And here I can just call it vector like that. Well, let me, instead of nums, let's, because our array, our information could be anything, I'll just call it data instead of calling my array nums. So far, so good? So really, what a vector is the masking, okay, is the masking of a dynamic array, allocated array, nothing else. So, so a vector is the masking of an array which is dynamically allocated. That's all what we're doing. So behind the vector is the array. The array is the most important item in there. Okay, so the vector is not the array, but the vector is masking the array that we need to be using. The array is keeping our data here. All right. So now in terms of creating my variable, again, here, this becomes vector. Let's make, put some nice names for it. I'll call this my vector. Why not? Like this, so that is much easier. Vector, my vector, and I can keep changing these things now. So wherever I had my array, I'm going to change it and I call it my vector. Again, I'm working slowly so that anybody who has a question can be able to ask me. So I've not changed anything. Nums has been changed to data. And so this whole thing here is no longer called, it's called my vector.data, my vector.data here, my vector.data here, etc., etc. So far, so good. Okay, my array.items, so everything else changes to my vector. It should have been able to do that. Okay, well, it's not a stupid question. So that's fine, I can answer that. I said the vector is the masking, okay? Or I can say that a vector is a concept utilized to mask, okay, the implementation of a dynamic array. The implementation of a dynamic array. Nothing else. Nothing else regarding the array has changed. The array is just the same. We have just masked it. Okay, we have just done nothing else, but we have masked the array. That's all what we have done. We have put a structure and we have put the array inside of that structure. We created a structure and our array, this guy, has been put inside of it. So we are sort of hiding it inside. We are masking it inside the vector. Okay, let's run this. Okay, so I'll try to run it. No problem. Okay, again, everything runs like a dream, no problem at all. So far, so good. All right, so remember here we used malloc, so we want to free the memory associated with this. So I could have come here and say free, and I can put in there, sorry, I can put in here my vector.data. Again, nothing has really changed from our implementation, or from how we have been implementing since last week of these arrays. Nothing has changed. The only important complete things that we have come up with is we said, well, the array, for us to work with the array, we need three things. We need the pointer or the array itself, the variable that basically tells us the capacity of the array, and an iterating variable that tells us the total number of items at single point in time for the array. And we decided we are going to keep those three things together, and what better tool to use than the C structure to be able to do that. So that's all what we have done. And here we have used the typedef keyword to create a synonym for the struct vector to be called in vector. And then we created an instance of the vector. So we said my vector is an instance of the vector. And we said those are 12 bytes. And what we have done is, let me draw this. So the diagram looks like this for my vector. So my vector is this, is assigned 12 bytes. And these 12 bytes is divided into 3 parts. One part is a pointer referred here as data. And then the capacity, the number of items, which is 7 in this case, and another variable, which is called items, which in the beginning is 0. The next line here, my vector dot data, is us now allocating memory from the heap using malloc to data. So basically we have said go to the heap and allocate enough memory equivalent to the 7, the size, which is 7. So basically we have created a memory or an array of 7 items like this. So this is where the data is being saved. Data goes in here. Our values, data or our values. Our values or data goes into this array. These other guys here, size and items, they're just helping us to really work with the array. That's all what it's doing. So size and items are 2 variables that are helping us, the assistants, in helping us to work with the array. One will help us track the capacity of the array, and one will track us the number of items we have put into the array so that we can know when the array is full. Okay, and how are we doing checking whether the array is full? We are running this while here. We could have done a for loop, but we did a while. So we are checking. This basically is checking whether the array is full. So we are saying while the number of items is less than the capacity of the array, then keep adding items into the array. Otherwise, the array will be full, in which case would have been done with the work and we could go on and do something else. So far, so good? Good. Awesome. So that's basically what we just created. Now, the other time we said, well, if we are doing all this work here, maybe we should create a function that does some of this work for us, so that the main becomes really a driver. So let's create a function. It's going to be a non-value returning function. So void. I'm just going to call it print items here. Remember, we could have one that populates. In fact, I can say here, let's do this. We're not going to return anything. So I'm going to say void add items. And what this will do, both of them, they are going to get a my vector. And then it's going to add items to the vector. And then the other one is going to print out items of the vector, right? So one is going to add items and the other one is going to print items of the vector. So I'm going to copy this. I'm going to paste it here. And I am going to then do the implementation. Instead of doing the implementation, I'm just going to copy this data over here. And I'm going to paste it here. And then I'm going to take, to remove this, because that's on a line we need to remove. Then I'm going to Okay, we already copied it. So I'm going to come up here and I'm going to paste it and I'm going to remove this. Okay, now there are going to be some errors. So I want you to track through and tell me what those errors are going to be, okay? But there are going to be some errors. So the first thing is to add items to the array. Now, I will call this array and try to add items to it. Now, let me remove this now. That's what I've done. I've removed the items there. And I'm going to call the function add items, this one. In fact, let's just copy them. Oh, so that's a good question, Colin. But so we sort of the word here masking. Of course, when people hear about masking, they think about hiding something, right? Right. When we say you're masking something, you're saying hiding, right? Maybe that's not. I'm using that word a bit loosely here because we are still not hiding it. We are going to start hiding it at some point. But right now, we are not hiding it. The array inside the struct, we are not hiding it. But what we're doing is we are grouping the items that we need to work with the array as one compact thing. Okay, and then we are using this struct or this item now called vector, this object called vector, every single time that we want to work with the array in question. So instead of working with the array straight on, we are working with vector because the vector is keeping all the other variables associated with the array. Okay, you're going to see more of it in a normal, well, in different languages, for example, in Java or C++, the vector itself could have some functions associated with it. And that's why we needed to make it look like an object, okay? And we're going to do that in C. So right now, I'm just trying to help you dip yourself into it, and then we are going to make it explode as we go back and forth, okay? So use the word here, the masking, to loosely connote that the array is inside of a structure, and then we need to go to that structure before we actually go into the array. All right, so if I paste these things here, adding items and printing items, what do you think could happen? Someone to tell me. If I was to run my code right now, what do you think could happen? Anything? If I was to run the code right now, what do you think is going to happen? I've compiled it, no compilation errors. Colin, yes, yes, the struct does the same thing. However, the struct is not the array. I think this is the bit that I may need to insist for you to understand. Okay, so let's bring it up. This struct vector here is the structure, is the struct. But the struct is not an array. The array is this guy here. See, the array is inside the struct. When we create this variable here called my vector is a variable of type vector. That variable, we said it has 12 bytes and is divided into 3 things. One of them is a pointer. So the pointer, which is going to mark for us the beginning of the array, pointer, we call it data, pointer, and then size, which is the number of items that the array can actually hold. So that's the capacity. And here is another variable called number of items, which is basically tracking for us the number of items in the array, the number of items that the array has. Okay, so we call these items. Now, so that's the structure. That's all. But the structure is sort of containing inside of it 3 things: the array or the start of the array, the size, which is the capacity, and the number of items that the array has at any single point in time. Let's go on a little bit. When we call this here, when we say my vector dot data here, and we say malloc, now that is saying now create the array. So how do we create the array? The array, because we are using malloc, the memory for the array is now going to be in the heap. So this will go into the heap and it will create an array looking like this. With how many items? 7 items. Dot size is 7. So maybe 1, 2, 3, 4, 5, 6, 7. So this is the array itself. So when I say that the vector or this struct is masking or sort of containing or hiding the array, this is exactly what I mean. The array can only be referenced or being accessed by first going through the structure. Is it much clearer for you now, Colin? Anybody else who is having difficulties, sort of relating these two concepts? Okay, so is it understood now how this thing is working? So we are sort of thinking we are going to build a structure. Think about, we are building a house, a structure, and in that structure we are going to keep an array inside. So that's what we are doing. So the vector or this struct is actually doing that. It's basically building the structure, and the array is inside that. That's why I said the vector is nothing else but the masking the implementation of dynamically allocated array. That's what we're doing there. Okay, so that's good. I asked a question. If I did these two functions, add items and print items, I asked whether anything would happen. And what I had just done was, let me get the shell. So there we are. I said, well, I have already sort of compiled it, no compilation errors. What happens when I run it? So what happens when I run it? Dot file like that. Oh, it keeps going forever and ever. Why is that? It's printing forever and ever. So, well, my vector dot size, I think that's a small problem here. So which we can sort of get. Let's get these items. So it does not see that my vector dot items, what it is. Okay, it's supposed to be 0. So my vector dot items, we started off with some values here. So items should have given us some items that we have, but according to this, what is my vector dot items? Remember, when it's printing here, it's going to go to my vector dot items less than my vector dot size. It seems that my vector dot items is basically 0 the whole time, and that's why it's going forever. Do you see that? Okay, somebody says, okay, so how do we go about that? Even if we did this, so updating it would mean something like this. Right? Updating would mean something like that, right? Go back and forth. That will be updating it. But what is my vector dot items? Let's say when we are adding items to these, what is my vector dot items? If we are printing this, remember when we tried printing out, even when it kept going, everything was zeros. Why is it zeros? Specifically, what I'm asking is, when we pass the way we passed here, are we passing by reference or are we passing by value?
Oh, is it because it's like in the function, it's not changing?
Yeah, so we are passing by value, which basically means that this, my vector here, is a local variable to this function, and this here is also a local variable to this function, right? So really, my vector, the one on here is basically this. My vector dot items is still 0, and my vector dot size is still 7. Okay. So if we didn't want to have these problems, what would we need to do?
Use pointers.
Use pointers. Okay, so one of the things I could do is I could start by having, instead of my vector being an instance of vector, I could start making it a pointer. So let me call this p vector. So now, instead of me having an instance of vector, I have a p vector, which is this p vector, which is basically a pointer to an instance of a vector, which basically means when I had this before, okay, let me get this guy. When I have that, I have 12 bytes of memory, right? When I have these, how many bytes do I have? Okay, when I have that, I have 12 bytes for p vector. When I have that, how many bytes do I have?
Would it still be 12?
What's the difference between that, what I have now, and this? Okay, let me do this. I'll call this my vector the way I had before. So I'll copy that, I'll paste that, and instead I'm just going to call that p vector. What's the difference between this one and this one? Names notwithstanding. What's the difference between line 23 and line 24? Yeah, good stuff, Beltran. One is holding an address and the other is a full struct. So these, the first one, my vector, is an instance of a vector. The other one, p vector, only holds the address of a vector. So this one has 12 bytes, and this one is likely to only have 4 bytes because this one is a pointer. It's only keeping an address. And what we can do actually, if we wanted to do a lot of things, we could just say this one is equal to the address of my vector for now. So remember, this can keep addresses, so we can say, well, it's keeping the address of my vector. And in that case, then we can use p vector as though it was my vector. So we could just do this. And then, because now p vector is a pointer, we can just use the pointer to struct operator to access our items. Look, I've not changed anything. I've just said p vector is a pointer to a vector, and therefore is going to keep the address of my vector. And if that is the case, then I can use my p vector all the time. Okay, so I'll change everything now to my p vector. Okay. Again, if these things start becoming confusing, let me know. Okay, so I can do that now. I can, if I want to have these my items here become vectors, I could do that. I'll just call it p vector. In fact, maybe I should call it p vec here. Okay, so I can pass here p vector, and I can pass it here p vector, yeah, like that. And I can do here p vector. I don't need to really free the memory because, sorry, yeah, I need to free this memory for the data, this one, and I can free that memory here. like that. So no problem at all. Add items now. We called this pvec. So now we can use that pvec. Now the number of items in the beginning is 0. So that's fine. We could be able to keep adding items to them. pvec.size, pvec items, pvec data, like that. So pvec data, pvec items, we get some items here and we can increment. So we know this would work, no problem. Here now we want to print not to the size possibly, but we want to print to the how many items that we have in the array. So we could actually have another integer here, int I equals 0. Okay, and then we can say while I is less than pvec.items, then we can increment I plus plus like that. And then so this was pvec. Okay. Are you following? So I've not changed much. I'm just changing just a couple of things just to reflect the items that we have. And there we are. So pvec.items, this was using pvec. This one is using pvec, and the other ones are using pvector. Okay, so I'll save this. I'll try running it. Okay. Okay, so we try running it. A couple of things. Sorry, I needed to do this. Okay. All right, quickly we finish up this and then we do something else. Okay. So no problem. Okay. If someone is having some issues with this sort of implementation, let me know, and we can do work on it. So that's good. You can change this, and now it compiles fine, no problem. So let's compile again, no problem. We run it, and works fine. So, well, it doesn't appear to be changing the values, but it's printing all of them. So let's see what is happening there. Where is it? So we are calling it pvector.data. We are adding some items, add items, pvector. So we go to add items, which is here, pvec items plus plus. So we get pvec, while pvec is less than p items. So maybe we could have started by pvec being 0. Okay, pvec items is whatever values that we had before. So while pvec items is less than pvec size, pvec data, pvec items, we get some value, pvec items plus plus, that will do our job for us. And then while items, then are we printing them out or what's happening? While item I is equals to 0. Okay, so here we are going to be printing from I, sorry. We're going to be printing from I, and then this is going to be I here. That was the problem. So this was not any much of a problem up here. Okay, I minus 1. All right, so that should be able to do the trick. Okay, so we run it, no issues. We run it again, and we still have our values up here. So we start from index 0 all the way, etc., etc. So we run it again just to make sure, and there we are. So far, so good. Now let's sort of go through what we have done. So our I here, so our I here contains the values. So okay, this is going to be a value at I and this will be our value to I plus 1. So this will give us our ith index. So index start at 0 will give us the value here, and the number of items we have is just one item, and then we can go back and forth with it. So what we have done is just basically nothing else than what we have been doing before, but now we are using a pointer. We are using a pointer to update this, which means that even when we add items here, those items are going to be reflected up here. Okay. Now, before we go, we still have a couple of minutes. So let me save this. And now, if you look at here, I had to create something called my vector to get the memory, right? And we said, well, my vector has the memory, the 12 bytes. P vector does not have the 12 bytes. What P vector has is basically just holding the address, right? So if I did not want to use these, what would I do to get enough memory to keep a vector? What would I need to keep a vector? Essentially, what I'm asking is, supposing I didn't have this, supposing I didn't have that, and I still wanted to be able to go on with the code the way, the way I was doing, what would I do? What would I do? How would I do? Remember what we said, a pointer holds an address, right? So initially, what we are doing for this, what I did before for this pointer to hold an address, I had to make something of type my vector, of type vector, so that this could keep an address. Supposing I didn't have that thing of type vector, how else would I get an address or a block enough that is keeping something of type vector? So look, I want you to first pay attention to this. This is what we did. We said P vector, so this is what is happening up here. We have something called my vector, which is basically gets a whole block of 12 bytes. Okay, one is for the data, and one is for the size, and one is for the items, the number of items. And then I got another, I got a pointer called P vector. This pointer here, let's think about this, the address here is 110A, that's the address. We got something called P vector, and we know P vector is a pointer that keeps addresses of vectors. So P vector, we just assign it the address of this guy. So this guy here is my vector. So we give that address 10A. And because now we give it some address, this address here of this block, we can use it. We can use P vector whenever. That's what I've been using the whole time. And I can pass it and I can do all the work with it. So imagining I did not have this. Let's imagine I did not have this line. What would I still do in order to get another block that looks exactly like this, that can contain these three things? Calloc or malloc? Good, that's a good answer. So another thing I could have done, instead of having this guy, I can remove this guy, and then I'll say malloc for me, size of vector. Give me, I'm asking Mr. Memory Manager, give me enough memory to store a vector. Remember, malloc returns a void pointer, so I need to typecast this back to the known type, which is the vector. So I need it to become a pointer to a vector. So instead of using what I had done before, I can ask the memory manager to give me some memory from the heap equivalent to a vector. Now I still have the same formulation, by the way. I have something in the heap that has 3 items, one for data, one for size, and one for the number of items. I still have that. And I have a pointer here in the stack, which is basically keeping this address. Maybe this address now is 20B. So that address is still being saved here. And I can use this formulation and it should be able to work fine. So if I run this code should work just like the previous code. No problem. File gives me the same thing. Now, because I use the word malloc here to allocate memory, then I must also free this p vector. The other very important thing is this. We created these things looking like this. So we have now something called p vector here. We have the p vector there. And then this p vector is keeping the memory of something which is in the heap, which looks like this. This is data. This is size. And this is items. So it's keeping this. So this is dynamically allocated. So I'll put it like this to say this is dynamically allocated. This is a dynamically allocated thing. And then when we created data here, we also used malloc. So I'll say also dynamically allocated. Okay, so this is our array now, which was dynamically allocated. So this was the first one to do. Then this was the second one to do. When I'm freeing up the memory, which one should I start with? When I free the memory, which one should I start with? Between the two of them, which one should I start with when I'm freeing the memory? Remember here, I called malloc here for this one to allocate, and I called malloc here also for this one. So if I'm freeing up the memory, which one should I start with? This one or this one? Number two. We should start with number two. That's correct. We should start with number two because we cannot be able to go to number two. We have to go through number one to go to number two. So if I free number one, if let's say I freed number one before I freed number two, I don't know how to go back. If let's say we freed number one, if we free number one before we free number two, there's no way for us to go to and free number two. See, there's no way to go free number two because our link is lost now. So we must start with number two and then free number one. So that's what I'm doing up down here. I'm freeing the block where the array is and then freeing the p vector. So far so good? And everything works fine now. Now, last thing, the last 4 minutes. Last time when we met, what we saw is that we could create multiple files to do this work for us. One of them was the header file. And what we did with the header file, we just took these things here, which I'm going to do. I'm going to take these things and I'm going to create a new document and I'm going to paste them here. And this is our header file. And I'm going to save this as vector.h. I'm just going to call it vector.h. Remember that, vector.h, which is basically just keeping the header files, this guy and all the items that we need. That's what we did last time. And then we created another file, which was a .c file, which was keeping all our function implementation. So I'm going to create that one, text document. I'm going to paste it here, and I'm going to save as vector.c. Okay. And what I'm going to do here is I'm going to include now that other one, vector.h. And I'm doing include vector.h. And I'm going to copy this and I'm going to paste it here. Or it could have been anywhere. And I'm going to save this as well. Okay, so now we have 3 files doing the same thing. So I could as well Now run it. Okay, now we're going to have some problems because I need to do all of them together. So remember what we said, we're going to do GCC wall, and then now all our file, vector.h, vector.c, and then our main vector, we run it. It's complaining about some stuff. Maybe there's something, a declaration for printf, where is the vector.h stdio, that was there. That should be able to see that. Okay, and this should be able to see that. Vector.h is here, vector.c is there, and vector.h is there. I should be able to do it, but for the sake of argument, instead of wasting a lot of time, I'm just going to include it for there for just now. Okay, so okay, why does it expect? I think I may have copied something and then I forgot to copy something else. So the main is here. This one is here. I'm hoping that I did not leave some things behind, and I don't have the time to debug that for now. These are the print items. I think everything should be fine. Let's just try to run it. If we can't run it now, I'm just going to check it out later on. It says size of vector, and it's sort of something is forgotten. P vector malloc. Oh, sorry, it's here. Sorry, it's here. We had not done that. So it was missing that. Okay, so no problem now. Everything's fine, and we can run this, and everything works as a dream back on. Okay, so we have run out of time now. So in short, in brief, what have we done today? We have looked at the idea of a vector, and we have decoded that a vector really is nothing else than a masking of a dynamically allocated array using a struct. So we are calling that struct vector, and inside of it, which is what we created here, is the array and the two variables that we need to work with the array, the size and the items. Now, we could make a bigger picture and say we can also have functions that work with our vector, which we can have and we are going to work with. For example, in this case, we had we added items to the vector, and we printed items to the vector. And we are putting all these things to the same file because this file does nothing else than help us work with the array. The data is being kept in the array. Our vector.c just has the implementations of the three files. And then our main basically has the creation of the vector itself, and also our allocation of memory, and also freeing the memory. When we look at this next time, we're going to use this same code, and we are going to separate most of these materials from being where it is and creating some functions to work with them. Okay, that's what basically the whole of next week is going to entail. So thank you very much. Any questions for me?
Oh,